QIDI Tech has a new high-speed printer in their lineup. Is it a fantastic 3D printer? No, but is it a pretty good printer? Also no, but it is a really fast 3D printer. Welcome back to Cloud42, I'm James. This is probably not going to be like any other review video you've seen. I want to be as transparent as I can be here. QIDI provided this printer to me free of charge in exchange for making this video. My terms for reviews are always the same. I'll use the product for a few weeks the way I would actually use it in my shop, and then I'll share my experiences with it. The manufacturer doesn't get to see the video in advance, and they don't have any control over the content or the schedule. I usually estimate that it will be 4 to 6 weeks, but I also tell them that I'll work with them first if I run into any problems, and I do this because I want to be as fair to them as I can be. And I also want to be able to share any tips or workarounds with you. Sometimes things go great, and sometimes they don't. And unfortunately, this one is the latter. But I think the way things came off the rails is pretty interesting, so let's take a look. This is the new QIDI Tech X-Plus3. Its primary marketing claim is that it is fast, really fast. They claim 600 millimeters per second and over 20,000 millimeters per second squared acceleration. And while that's possible, printing speeds between 200 and 300 millimeters per second are probably more realistic. It's a Core XY printer with carbon fiber gantry tubes, and they claim the speed comes from a reduction of the moving mass from something like 1.6 kilograms to only 600 grams, which is about what you'd need to get it to go that fast. One downside of this is that the gantry is actually running on those carbon fiber tubes, and you have to keep them clean to slow down the wear. There's even a sticker on the top of the printer that warns you that they can't be replaced, so you'd better keep them clean. The printer comes with 2 high-flow hot ends, one with a hardened nozzle for abrasive materials and one with some kind of copper alloy nozzle for better thermal performance for non-abrasive materials. Has a 280 millimeter square bed with the usual powder-coated spring steel bed sheet, automatic bed leveling, and a heated chamber that can go up to 65 degrees, though I've seen different numbers quoted. I've been running it at 55°C, and it seems to do that easily. The printer's running Clipper, and it does have input shaping for vibration damping. If you don't know what that is, it has an accelerometer in the head, and it runs through a calibration cycle where it vibrates the machine and measures the mechanical response, and then it applies compensation for that vibration while it's printing to try to cancel out ringing in the print. On paper, it's a very capable printer, and they're clearly positioning it to go against the Bamboo Lab X1 Carbon. In fact, if you look closely enough, you'll see a lot of familiar design details. The biggest gap, however, that I see right up front is that it does not have a webcam. Seems like that's probably just a value engineering decision. There's plenty of room inside for one, and as Robert Cowan pointed out to me, Clipper supports webcams natively. All you need is a spare USB port on the board, and in fact, if you open up the back of the printer, there is indeed a spare USB port, and if you plug in a webcam, it pops up in the Clipper UI, so I guess you can add one if you want. When I got the printer, I did what I always do. I took it out of the box, ran the calibration, and printed a Benchy. And it was fast, like Benchy in 15 minutes fast. And it doesn't look too bad either. If you've never seen one of the new crop of high-speed 3D printers in action, it's shockingly fast. After seeing that first job, I was pretty positive about the machine. I do a lot of production printing in ABS, and if I can cut my print times in half, that's a huge win for me. So I loaded up some ABS and started testing, and that's when I started running into problems. The first problem I encountered is the Z height. Getting the first layer to lay down consistently has taken me 3 weeks, a couple of firmware updates, and new parts from QIDI, and there are still deep-seated design issues that I think are going to be really difficult for them to overcome. We'll talk more about that in a minute. The second major problem I've been having is extruder jams, or rather hot end jams. When the printer is closed up with the heated chamber enabled for ABS, there just isn't enough cooling capacity in the extruder. Heat creeps into the cold end, the filament swells, and it jams hard, have to disassemble everything to clear it hard. We'll talk more about that too. There are a bunch of other minor issues. The fans are loud, there are bugs and glitches in the control panel and the UI, but none of that matters for me because I can't get the printer to run reliably. There are reviewers out there who have positive things to say about this printer. I know of at least one other person who's been primarily running PLA with the printer open with some measure of success. So your mileage may vary, but it's not working very well for me. When I got the printer, the Z height was being controlled using an optical sensor at the bottom of the bed travel. It would home at the bottom and then remember its position from there. You calibrate the nozzle offset using a plastic shim they provide, and it just does the math. And that would work if everything were stable, but of course everything is not stable. The biggest underlying issue is that the bearings that support the bed screws are not attached to the metal frame of the printer. They're mounted in the molded plastic bottom skin of the chamber, and this plastic moves as it changes temperature, and this changes the Z offset by as much as 0.5 millimeter. If you put a dial indicator on the bed and press on the plastic bottom of the printer, you can see this easily. And if you just turn on the chamber heater and let it sit, the bed rises over 0.5 millimeter over the course of an hour. By the way, the indicator I'm using here is called the initial layer. It's normally used for precisely adjusting printers with manual bed leveling knobs. I'll put a link to that down in the description if you're interested. And this isn't just the bed. I mean, the bed does change shape as it heats up too, but the whole bed is rising. And what that means is that if you have the printer calibrated and the Z height is perfect when starting cold, you can run a 15-minute print and it'll be just fine. And if you then run another, it'll be a little bit higher. And if you run another, it'll be a little bit higher still. And by the 4th or 5th print, the nozzle is scraping on the bed sheet. So if you're printing a job that takes a few hours and the first layer goes down perfectly, you're not home free because a full 0.5 millimeter of height is going to be taken out of the print over however many layers it can print in the first hour. My feedback to QIDI was that the printer already has a proximity sensor for the auto bed leveling, and they should just be using that to set the Z height, and they should do it at the start of every print. They took that feedback and they sent me a new version of the firmware that does exactly that, except it didn't work because the inductive sensor in the printer was temperature sensitive. So it got even crazier. Depending on the current temperature of the whole system, it was getting different Z readings and it was basically impossible to calibrate. To solve this, QIDI then sent me a new temperature compensated probe, and that seems to solve the whole Z height issue. I found that I also had to turn on the G29 auto bed leveling. There's a switch in the slicer for that if you turn on the advanced options. So it also runs that at the start of every job to compensate for the change in the shape of the bed as it heats up. But with that, it will indeed lay down the first layer reliably. At least the first part of the first layer, because even if you correctly measure the initial Z position, the bed's still going to rise a 0.5 millimeter during that first hour if you're using the heated chamber, and that slack is going to get taken up somewhere in the print, and that's going to affect the dimensions and the wall finish. So with the bed level basically working, I moved on to testing with some larger objects, things that I would actually want to print on the machine, and that's when I discovered the jamming issue. The hot end on a 3D printer has a hot part and a cold part. The filament is supposed to be guided by the cold part into the hot part where it melts. The hot end is constructed with a narrow heat break to avoid migration of heat into the cold end, and the cold end has a fan and a heat sink to cool it. If the filament in the cold end gets hot, which is referred to as heat creep, it'll swell up, jam, and then it'll just stop feeding. I suspect this printer might work fine with filaments like PLA that are printed with the cover off and the chamber unheated, but when printing ABS, the interior of the chamber is at 55 degrees, and right over the heated bed, it's probably even hotter, and this little hot end and the fan on it just don't have enough cooling capacity, and it jams. I tried multiple different prints over and over again with different settings, trying to keep this from happening, and just could not get it to work. QIDI support kept telling me to increase the extruder temperature. The ABS I'm using is marked with a max temperature of 240, and they were telling me to print at 270, 290, or even 300. I tried it, and I did manage to get a single largish print out of it by printing at 270 at about 250 millimeters per second, but at that temperature you can see visible smoke coming off the filament as it extrudes, and when you stop it literally drips out of the nozzle in big drops onto the bed. But I did finish a part and it looks okay. It's a little swollen at the bottom, again probably because the bed is rising as it prints. And it does have a lot more ringing than I would expect, but it did finish. So I tried another job with the same settings and it immediately jammed after only a layer or two. Maybe it's possible to print reliably if you aren't using the heated chamber or with a different filament or something, but as it is, it's so sensitive to the exact conditions that it just isn't useful for me. I need a tool that just works, and this isn't that. So my conclusions, it's a swing and a miss. There is no reason that this product couldn't be great, but in its current form, it just doesn't work for my needs. For this to work as advertised, I think QIDI needs to do three things. One, change the internal structure of the printer. The frame needs more steel and it needs to rigidly connect from the gantry all the way down to the bed screw support bearings. Maybe even put the thrust bearings at the top of the screws. The XCF Pro handles this really well, but of course, it costs more than twice as much. Second, fix the thermal design of the hot end. The cold end needs better cooling, and this will be challenging since it needs to operate in the heated chamber and it still needs to be lightweight. But other printers have solved it, so it is possible. And third, spend some time cleaning up the clipper integration. There are lots of little bugs and glitches and lots of places where controlling things through the web UI messes up the touchscreen. And I guess 4, it needs a webcam. I already mentioned that. I really hate leaving a review like this, but this is what I experienced. Maybe it'll work better for you. Maybe you're using PLA. Maybe you don't need the heated chamber. I don't know. I didn't test that because that's not what I print. I spent 3 weeks doing free testing and consulting work on this one, and unfortunately, it didn't work out for me. So I'm going to keep looking. Thank you for watching.